Okay, in this video we're going to have a look at covalent bonds to form molecules. Before we do this, let's just remind ourselves of a key idea, core knowledge. A covalent bond is formed when atoms share a pair of electrons. So we're looking to make these form bonds that are going to be shared pairs of electrons in order to become stable. So here's my first elements that's going to be involved. I've got my hydrogen and I've got my chlorine. We know that chlorine's electron configuration is 287, but all I'm drawing here to keep it simple is just the outer electrons. So that's the 7 electrons in the outer energy level. These are going to have to overlap in order to share that pair of electrons. So here we go. Here's these overlapped. Hydrogen shares its 1 because it needs to end up with a share of 2. In order to make the bond, chlorine will also share 1 electron. So there's my shared pair. And that leaves chlorine with these electrons sitting outside. 1, 2, 3, 4, 5, 6. And that's the 7th one. If you just double check and cover this over, chlorine's now got a share of 1, 2, 3, 4, 5, 6, 7, 8, which makes it stable. Hydrogen has got a share of 2, which also makes it stable. So there we have our molecule. Look at my next example for you. Just pop this on. So here's my next example. This is carbon bonding with hydrogen. It's going to form methane. So again, you can see how I've got my outer electrons only drawn. So the carbon with 4 electrons, the outer energy level, and I've got my hydrogen with just 1. In order to make this work, this is going to need a share of 4 more. So I'm going to need 4 of these to bond with the carbon, 4 more hydrogens to bond with the carbon to make the molecule. So that's what I've drawn here. In this case, each carbon is going to share 1 of its electrons. So 1 here, 1 here, 1 here, 1 here. And the 4 hydrogens are going to have to share their electrons in order to make the shared pair of electrons, that covalent bond. Check again, carbon has got 1, 2, 3, 4, 5, 6, 7, 8 electrons being shared, so that's stable. And each hydrogen has got a share of 2, so that is also stable. So that's my molecule of methane. One more just to show you. I'm going to come back to my original example. Let's just swap this over. We'll cover that for a moment so it doesn't get in the way. And here we're going to look at oxygen. Oxygen is a little bit different, one to watch out for. So we've got my 2 oxygen atoms. Remember, I'm only drawing outer electrons, so they've got 6 electrons each in the outer energy level. And in order to become stable, we talked about sharing a pair of electrons. So if they just share 1 each, so this shares 1, and this shares 1, you can see that if I take away just 1 of these, because this would have all the other electrons here, so it's got 1, 2, and then 3, 4, 5, 6, 7. So you're going to have 7 electrons. That isn't going to work, that's not stable. So it has to share 2, and therefore the other one has to share 2, and that leaves this with 1, 2, 3, 4, because there's 2 being shared, so there's 4 left here. Do the same on this side, it's sharing 2, so those 2 are being shared, and then we've got 1, 2, 3, 4, and if we just double check, this electron, this oxygen atom here has got 1, 2, 3, 4, 5, 6, 7, 8, so it's a share of 8, so that's okay. On this side, we've got a share of 8 also, so that's stable. This is 2 pairs of electrons, so this is a covalent double bond to form this molecule.